In this video, we will be introducing ourselves to word problems. Specifically, we will familiarize ourselves with the implication of different words and expressions. Being able to translate the various expressions to math forms 90% of the requirement to be good in solving word problems. Let's look at the most common expression used, addition expression. The following expression implies addition. 1. Increase by. 2. More than. 3. Added to. 4. Sum. 5. Comparative words that denote more than. Longer, faster, taller, and so on. If we have 5 increased by 3, this is the same as 5 plus 3. If we have 2 more than 8, this is the same as 8 plus 2 or 2 plus 8. You can interchange numbers in addition. Subtraction expressions. The following expressions imply subtraction. 1. Decrease by. 2. Less than. 3. Taken from. 4. Subtracted from. 5. Difference. 6. Comparative words that denote less than. Smaller, shorter, slower, and so on. One important thing to know about subtraction expressions is the order matters. If we have 8 decreased by 5, this is 8 minus 5. This is straightforward. But if you have less than, the second number is written first, or we can say it's written backwards. So 8 less than 5 is 5 minus 8. Notice we had the 5 first. We say that for addition, order doesn't matter. For subtraction, if you have less than, subtracted from, taken from, or any of the comparative words that denote less than, we write the second number first. He is 2 years younger than X. This will be X minus 2. Notice, we wrote the X first and the 2 second. Multiplication expressions. The following implies multiplication. 1. Multiply by. 2. Times. 3. Twice, thrice, double, triple, and so on. 4. Product. So, if we have 2 multiplied by X, that will be 2 times X, which is simply 2X. Division expressions. The following implies division. 1. Divided by. 2. Quotient. 3. Shared equally. 4. Per. If we have 20 shared equally among 4 boys, this will mean 20 divided by 4. Next, we look at expressions that implies equal to. 1. Is. 2. Was. 3. Gives. 4. Becomes. 5. Equals. So, if we have 2 plus 3 is 5, it's the same as this. The is meant equal to. Finally, to solve most word problems, you have to identify your unknown value and represent the unknown value by X or any letter you prefer. Example, if we say number minus 4, we do not know that number, so we can represent it by X. So we have X minus 4. We will end this video here. Increase by 4. We know that increase by means addition, so this will be 2 plus 4. Number 2. Twice a number is 4. We see 3 key words. We know that twice means multiplication, exactly 2 times. We know that a number is our unknown, so we can represent it by X. Finally, we have is, which we know means equal to. We can write this as 2 times X equals 4. 2 times X is the same as 2X, so we have 2X equals 4. Number 3. 7 more than 3 times a number was 20. We have 7. More than means additions, so we have plus. A number is our unknown. We can represent it by X. So 3 times a number will be 3 multiplied by X, which is 3X. Finally, we have was, which means equals. So we have equals 20. Our unknown doesn't always have to be represented by a number. Example, 3 times Rachel's age is 5. Here the unknown is Rachel's age, so we can represent it by X. This will be 3X equals 5. If we have $10 subtracted from Joel's money becomes $30. Here we have becomes. We know that means equals. So we have equals 30. Next, Joel's money is our unknown, so we represent it by X. Remember, we learned in the previous video that when you have subtracted from, you will write the second thing first. So 10 subtracted from Joel's money is X minus 10. Important use of parentheses. Before we end this video, we want to look carefully at these 4 keywords: sum, difference, product, and quotient. We already know that sums means addition, difference means subtraction, product means multiplication, and quotient means division. But these terms denote a group, and it is necessary to put them in parentheses. Then work from there. Example, the sum of 2 and X is 12. So here we can write it this way. Notice that "and" is what is between the two numbers that we are adding. Let's look at these two statements. 4 times 3 plus 5, and 4 times the sum of 3 and 5. We notice that in both cases we have two operations. We have times, which means multiplication. We have plus for the first statement and sum for the second statement, both meaning addition. These statements does not mean the same thing and will nor yield the same results. The first one is straightforward. 4 times 3 plus 5. From our order of operations, we do our multiplication first, then our addition. We multiply the 4 and the 3 to get 12. Then we add the 5 to get 17. Let's look at the second one. Again, we have 4 times, but here we have the sum of 3 and 5. We said we put this in parentheses, so we have this. From our order of operations, we know that we have to do parentheses first. So here we will add the 3 and 5 to get 8. Then we will multiply 4 by 8. This will give us 32. If we had not put it in parentheses, we would have solved it as 4 times 3 plus 5, and we would have had it wrong. I hope this example helps you understand why we are making a big deal out of using parentheses for sum, difference, product, and quotient. Leslie's age is 3 years more than twice Victor's age. If the sum of their ages is 48, what will Leslie's age and Victor's age be? The first thing I like to do when solving any word problem of this nature is to identify my subject or thing the question is about and represent them with letters. Here we are looking at Leslie's age and Victor's age. We can represent Leslie's age by L and represent Victor's age by V. Now, let's go sentence by sentence and translate the word problem into math. Leslie's age, which we represent by L, is, we know that is means equals, 3 years more than. We know more than means addition. Twice Victor's age means 2 times Victor's age. We represented Victor's age with V, so this can be written as 2V. Next, we are told that the sum of their ages is 48. We know that sum is addition. We are adding their ages, so we have L plus V is 48, which is the same as equals 48. Now we've been able to set up the word problem. We are going to use substitution to solve it. I will label this equation 1 and label this equation 2. Since L is 3 plus 2V, we can substitute the L in equation 2 with 3 plus 2V. We have 3 plus 2V plus V equals 48. We solve for V. We have 3V equals 48 minus 3. V equals 15. So here we have Victor's age as 15 years. But the question wants us to find Leslie's age also. To find Leslie's age, we can substitute V equals 15 in equation 1. We have L equals 3 plus 2 times 15. We solve for L to get 33. Leslie's age is therefore 33. We can see that there are 2 things needed to solve this question, and you have to be a master in both. 1. You should be able to translate the word problem. 2. You should be able to solve the equation, in this case, the simultaneous equation. We are still looking at word problems. Here we want to look at implied meaning. You are not always going to get all word problems having a direct translation to math. Let's solve an example to explain it. A farmer sold a horse and a cow for $210. He sold the horse for 4 times the price of the cow. How much did he get for each? Again, I start by identifying the things the question is about. It's about the price of a horse and the price of a cow. I will represent the price of the cow by C and represent the price of the horse by H. Now, let's read the question and translate it. A farmer sold a horse and a cow for $210. This statement does not follow any of the things we learned about the direct translations. We can, however, notice that this means the price of the horse plus the price of the cow equals 210. We call this our equation 1. He sold the horse for 4 times the price of the cow. Here again, apart from the 4 times, nothing follows the direct translation we've been learning. But we can see that this statement has the same meaning as the price of the horse is 4 times the price of the cow. So we can say that H equals 4C. This will be our equation 2. So we are done with our setting up. Next, we want to use substitution to solve the equation. We can replace the H in equation 1 by 4C. Now we have 4C plus C equals 210. We solve for C. We have 5C equals 210. C is therefore 42. Next, we can substitute 42 for C into equation 1 or 2 and solve for H. I choose equation 2. We have H equals 4 times 42. We multiply to get H equals 168. So the farmer sold the horse for $168 and the cow for $42. To be able to solve this question, you need to understand the implied meaning and translate it to mathematics. Then, as usual, solve the resulting equation. In this case, simultaneous equation.
In this lesson, we're going to talk about percent proportions. In a percent proportion, the ratio between the part and the whole is equivalent to the ratio between the percent and 100. So therefore, you can set it up as an equation or proportion. So here's the equation that we're going to use. The part divided by the whole is equal to the percent divided by 100. So let's work on some problems using this equation. In the first case, the first type of question we're going to solve is finding the percent. So here's the first one. 20 is what percent of 45? Feel free to pause the video if you want to try it. So we have part divided by whole is equal to percent over 100. I probably should have moved this equation in the middle. Now there's something I want to add to this equation, so this will help you in the future. The part is associated with the word is, or the number that's associated with the word is, and the whole is the number that is associated with the word of. I think that's going to help a lot. So you need to recognize that 20 is the part, 45 is the whole, and we're looking for the percentage. So P is 20, W is 45. The percent, since that's what we're looking for, let's call it X over 100. So now what we need to do is cross multiply. 45 times X is simply 45X. And then we have 20 times 100, which I'm going to leave it like this. Now 45, let's divide both sides by 45. So X is going to be 20 times 100, which is 2,000, and 2,000 divided by 45 is about 44.4. So that's the answer. 20 is 44.4% of 45. Here's another similar example. What percent of 12 is 27? Feel free to try that problem. So we're going to use the same equation. Part divided by whole is equal to percent divided by 100. The percent, we're going to make it x. Now, what is the part and what is the whole in this problem? The number that is associated with is the part. So 27 is the part. The number that is associated with the word of is the whole. So 12 is the whole. So what percent of 12 is 27? Whenever the part exceeds the whole, your percentage is going to be greater than 100. Let's go ahead and find a value of x. So what we have is 12x, after cross multiplying, is equal to 27 times 100, which is 2700. Now all we need to do is divide both sides by 12. And then this is going to give us the answer. So 2700 divided by 12 is 225. So 27 is 225% of 12. And so that's how you could read the sentence if you want to. But that's the answer. Now the second thing that we need to talk about is how to find the part. This question is going to illustrate it. What is 32% of 86? So let's write the equation first. We have the percentage, 32%. Now the number that's associated with the word of is 86, and that's the whole. So we're looking for the part, which we can replace it with x. And now we just got to cross multiply. So x times 100 is 100x, and 86 times 32, let's find the value for that. That's going to be 2752. So all we got to do is divide 2752 by 100, and that's equal to 27.52. So 27.52 is 32% of 86, and that's the answer. Here's another example. What number is 21% of 250? So we're looking for the part once again. Let's replace p with x. The whole is the number associated with the word of, that's 250. We have the percentage, which is 21%, and let's cross multiply. So once again, we're going to have 100x is equal to 250 times 21. 250 times 21 is 5250. Now let's divide both sides by 100. 5250 divided by 100 is 52.5. So 52.5 is 21% of 250. By the way, 50 is 20% of 250. 20% is 1/5. The last thing that we need to cover is finding the base. So here's a problem that will illustrate this example. 30 is 45% of what number? So go ahead and pause the video, and you can try this if you want to. So let's start with the equation. Part divided by whole is equal to the percentage divided by 100. So in this problem, what is the part and what is the whole? 30 is the part. It's associated with the word is. We're looking for the whole, which is also known as the base. We're looking for the number that's associated with of. So 30 is p, the whole or the base is x, the percentage is 45. So let's cross multiply. 30 times 100 is 3000, x times 45 is 45x. So let's divide both sides by 45. 3000 divided by 45 is 66.7. So that's basically the value of x. So that's the base. So 30 is 45% of 66.7. Here's another example. 22 is 34% of what number? So in this example, we can see that the part is 22, and we have the percentage, which is 34. We need to find the whole, or the base. 22 times 100 is 2200, and x times 34 is 34x. So let's find the value of x by dividing both sides by 34. 2200 divided by 34, that's 64.7 if you round it. So 22 is 34% of 64.7. And so now you know how to use the percent proportion formula in order to find the part, the percent, or the base, which is also known as. Now let's work on problems involving ratios and proportions. Let's start with this one. A certain island contains 540 cats and 675 dogs. What is the ratio of cats to dogs on this island? One way in which we could do so is by setting up a fraction. Since cats came first, we're going to put it on the top of the fraction. And dogs came second, so we're going to put that on the bottom. So there's 540 cats and 675 dogs. Ratios and fractions, they're interconvertible. You can put a ratio into a fraction, or you can convert a fraction back into a ratio. Right now, what we need to do is simplify this fraction. Now, because the last number of 540 and 675 contains either a 0 or a 5, both numbers are divisible by 5. .540 divided by 5 is 108. 675 divided by 5 is 135. Now, we need to simplify this further if possible. So what number goes into 108 and 135? Well, let's find out. It turns out that both of these numbers is divisible by 9. 108 divided by 9 is 12. 135 divided by 9 is 15. Now we can reduce it even further. 12 is 4 times 3. 15 is 5 times 3. And so we could cancel a 3. So the ratio of cats to dogs is 4 to 5. Or we can write it like this, using a colon. So that's it for this problem. Now let's move on to number 2. The ratio of boys to girls in a class is 8 to 7. If there are 40 boys, how many girls are there in the class? So what we're going to do is we're going to put the information relating to the boys on the left side and the information relating to the girls on the right side. We need to set up a proportion. We need to write two fractions separated by an equal sign. Now the ratio of boys to girls is 8 to 7. So that means that if there are 8 boys in a class, there's going to be 7 girls in that same class. Now if there's 40 boys in a class, how many girls, or X, will be in that same class? So this is the formula that we need to solve. Let's cross multiply. So this is going to be 8 times X, and that's going to equal 40 times 7. Now we could multiply 40 by 7. 4 times 7 is 28. Add the 0, you get 280. But it's easier if we rewrite 40 as 8 times 5. Notice that we can cancel an 8. So on the left side, all we have is an x left over. On the right side, it's going to be 5 times 7, which is 35. So if there are 40 boys in a class, there's going to be 35 girls in that same class. And you could think about it conceptually. So let's say we have the ratio 8 to 7, and we want to expand it to 40 to some unknown number. To go from 8 to 40, we need to multiply by 5. So therefore, to keep the ratio the same, we need to multiply 7 by 5, which will give us 35. And that's a quick way to get the answer mentally, if you see it that way. Try this one. Karen can make 14 cakes in 6 hours. How many cakes can she make in 15 hours? So what do you think we need to do to solve this problem? Well, let's set up a proportion. There's two things that we're dealing with: the number of cakes that she can make and the time in which she can make them. So once again, let's put two fractions separated by an equal sign. So she can make 14 cakes in 6 hours. So how many cakes, which means x, that's what we're trying to solve for, can she make in 15 hours? So all of the information associated with time is on the right side, and the information associated with cakes is on the left side. And since 14 cakes correspond to 6 hours, these two things are on the top of the fraction. The other stuff has to be on the bottom. So now let's cross multiply. This is going to be 6 times x, and that's going to equal 14 times 15. Now 14 times 15 is 210. So now, in order to separate 6 from x, we need to divide them. We need to divide both sides by 6. So it's going to be 210 divided by 6, which is 35. So in 15 hours, she can make 35 cakes. So that's the answer. Now let's see if we can do it the fast way. So the ratio of cakes to hours is initially 14 to 6. And we want to know how many cakes, or x, she can make in 15 hours. So we have these two numbers. What do we need to multiply 6 by to get to 15? 6 times what number is 15? If you're not sure, divide. 15 by 6 is 2.5. So you got to multiply 6 by 2.5 to get to 15. Likewise, to find x starting from 14, you must also multiply that by 2.5. 14 times 2.5 will give us the same answer, which is 35. Number 4. The length and width of a small rectangle is 9 inches and 8 inches respectively. The length of the large rectangle is 24 inches. If the length and the width of the two rectangles have the same ratio, what is the width of the large rectangle? Well, let's set up a proportion. So we have the large and the small rectangle. Now let's say the top portion represents the length of the two rectangles, and the bottom part of the two fractions represents the width. So the length and the width of the small rectangle, the length is 9 inches, and the width of the small rectangle is 8 inches. Now for the large rectangle, the length is 24. Our goal is to calculate the width of the large rectangle. So let's put an x. Now let's cross multiply. So this is going to be 9x, and that's equal to 8 times 24. So 8 times 24, actually before we do that, let's write 9 as 3 times 3 and 24 as 8 times 3, because this will help us to give our answer as a fraction so we can get an exact answer as opposed to a decimal value. So right now we have 3x on the left. 8 times 8 is 64. Now let's divide both sides by 3. 3 doesn't go into 64, so we can leave our answer as 64 over 3. So that is the exact answer of the width of the rectangle. But if you want to turn that into a decimal, this is about 21.3, or you could say 21.3 repeating. And the units, inches. So that's it for this problem. Number 5. The ratio of nickels, dimes, and quarters in a jar is 3 to 4 to 7, respectively. If there are a total of 112 coins in the jar, how many of them are nickels? So this is a multi-step problem. Feel free to pause the video and try it. So we can set up many fractions to get the answer. We're going to have nickels, quarters, dimes, or let me put nickels, dimes, quarters. Let me follow what we have here. And then I'm going to add another category, that is the total. So in this case, we're going to have 4 fractions. On top, I'm going to put the ratio. If there are 3 nickels, there's going to be 4 dimes and 7 quarters. In this case, the total number of coins will be 3 plus 4 plus 7. That's going to be 14. So this is based on the ratio. On the bottom, I'm going to put the actual number of coins in the jar. The total number of coins in the jar is 112. Now, I can calculate the number of nickels, dimes, or quarters. It doesn't matter. However, we want to focus on the number of nickels. So we can put an X here, or if you want to, you can put N for nickels. So all I need to do is set this fraction equal to this one. So 3 over N is equal to 14 over 112. Now, let's say if I wanted to calculate the number of dimes, I would put D for dimes and set these two equal to each other and solve for D. Or, if I want to solve for the number of quarters, I would set these two fractions equal to each other. So I can calculate the number of dimes, nickels, or quarters, whichever I want in this problem. But let's focus on N. So let's cross multiply. This is going to be 14 times N. And that's going to equal 3 times 112. 3 times 112 is 336. Now let's divide both sides by 14. 336 divided by 14 is 24. So there's 24 nickels in this jar. And so that's it for this problem. By the way, if you want to find the rest, here's what you can do at this point. Let's write our ratios of nickels, dimes, quarters, and the total. So it's 3 to 4 to 7 to 14. Now for nickels, we have 24 on the bottom. To go from 3 to 24, we need to multiply by 8. And if we multiply 14 by 8, that will give us 112, the total number of coins. To find the total number of dimes, we need to multiply 4 by 8. 4 times 8 is 32. And to find the number of quarters, it's going to be 7 times 8, which is 56. And you could check it. If we add 24, 32, and 56, it should give us the total number of coins in the jar, which is 112. So there's 24 nickels, 32 dimes, and 56 quarters.